Hello, dear students. I again welcome you in our online lecture 7th on chapter 3 D block element of our chemistry paper first, that is physical and inorganic chemistry. We have discussed so many properties on D block elements. Now we will discuss about the properties of these elements, that is oxidation states. You have already aware about this oxidation state term. So what is the oxidation state? See, the oxidation states means it is the charge left on the central atom when all the other atoms of a compound are removed. So this is oxidation state. What it is? It is the charge left on central atom when all the other atoms are removed. See what is central atom. Consider a molecule or compound that is KMNO4. You know what is KMNO4? KMNO4 means potassium permanganate. Now in potassium permanganate, manganese is a central atom. So manganese has its oxidation state. So if we want to know the oxidation state of manganese in KMNO4, we have to remove this potassium and oxygen, 4 oxygen. So after removing this potassium and 4 oxygen, we will get a charge on manganese, that is on Mn we get a charge, and the charge is +7. So this +7 is nothing but it is a oxidation state after removing potassium and 4 oxygen atoms. So what is oxidation state? It is a charge left, means this charge, positive charge +7 of manganese is a charge. So the charge left on the central atom when all the other atoms of a compound are removed. So we have taken the example of KMNO4 manganese. Mn is a central atom and 4 oxygen and potassium is the other atom. So when we remove potassium and 4 oxygen from this KMNO4, we will get a +7 charge on manganese. So +7 is the oxidation state of manganese. So another definition of oxidation state is it is a formal charge on an atom in a compound or an ion is called as oxidation state. Whatever the charge is acquired on an atom, that charge will be its oxidation state. For example, oxygen has charge -2. So -2 will be its oxidation state. Same way, hydrogen has +1 charge. So plus 1 charge is its oxidation state. So whatever the charge is acquired by any atom or ion, that is called as oxidation state. So it may also define as the number of a charge. See this definition. It is a number of charges on atom would have in a molecule or ion if electron were transferred completely. So when any electron is transferred from one atom to another atom, so whatever the charge is acquired by any atom, that charge will be a oxidation state. So now I think you get clear about what is oxidation state. Now next, see in this peak you will get clear what is oxidation state in simple way. See in this peak we have to consider this atom. See this is an atom and this atom is a sodium. So when this sodium atom lose one electron, this sodium atom will acquire this +1 charge. So +1 charge is its oxidation state after losing this 1 electron. Okay, then if we consider this chlorine atom, when this chlorine atom acquire this electron from another atom, consider from this sodium. So when this chlorine atom acquire this electron, this chlorine atom acquire -1 charge. So here -1 charge is the oxidation state of this chlorine. Okay, so due to the transfer of electron from one atom to another atom, the atom acquire some oxidation state In this peak, it is clear that after losing one electron by sodium, sodium has acquired plus 1 charge, and when chlorine accept one electron, see this electron, when chlorine accept this electron, then chlorine acquire minus 1 charge. So plus 1 charge is oxidation state of this sodium, and minus 1 charge is oxidation state of this chlorine. So plus 1 and minus 1 is a oxidation state. So whatever the charge is acquired by any atom or an ion, that is called as oxidation states. I hope you have cleared very well. Now, how we can find the oxidation number? Oxidation state and oxidation number both are same. Okay, so if we want to calculate the oxidation state of this H2SO4, so you have to do this calculation. So consider, see, in H2SO4 there is 2 hydrogen. See, in this equation there is 2 hydrogen, 1 sulfur and 4 oxygen. Okay, in H2SO4 there is 2 hydrogen, 1 sulfur and 4 oxygen, and hydrogen has oxidation state plus 1. See, hydrogen has oxidation state plus 1, while oxygen has oxidation state minus 2. So putting the oxidation state of hydrogen, that is plus 1. See, in this equation hydrogen has plus 1 oxidation state, and sulfur oxidation state is unknown to us. So sulfur's oxidation state we will write X. See, this is X. Okay, so hydrogen has oxidation state plus 1, sulfur has oxidation state unknown, that is X, and oxygen has oxidation state minus 2. Okay, so by solving this equation, you will get this equation. Okay, plus 2 plus X minus 8 is equal to 0. See, addition of all these oxidation states is always equal to 0, because H2SO4 is a neutral compound. H2SO4 is a neutral compound. There is no charge on this H2SO4. That's why the addition of all this oxidation state will be equal to what? 0. So remember this. So after solving this equation, you will get this answer: plus 2 plus X minus 8 is equal to 0, and the value of the X will be plus 6. See, X is equal to, you can solve this, 8 minus 2. So answer will be 6. So X has value plus 6. There is no minus charge. That's why the answer of 6, the charge of 6 will be plus. So oxidation state of this sulfur is plus 6. Okay, so in this way you can calculate the oxidation state of central atom. We have taken the example of this H2SO4. So while putting the oxidation state of all the other atom, that is oxygen and hydrogen, you can calculate the oxidation state of this central atom, that is sulfur, by putting its unknown value, that is X. By solving all this equation, you will get the value of X, and therefore you can write oxidation state of sulfur is plus 6. Same way you can calculate this oxidation state of KMnO4 easily. KMnO4, so oxidation state of manganese in KMnO4 is plus 7, because oxidation state of potassium is plus 1, manganese will be X, and oxygen has minus 2. So the number of oxygen is 4 times. So that's why by solving all this equation, you will get the value of X is equal to plus 7. Okay, the multiplication of 4 into minus 2 will be minus 8, and plus 1. By taking out the value of X, you will get answer plus 8 minus 1. So 8 minus 1 answer will be plus 7. Okay, so in this way you can find the oxidation number. So oxidation state and the oxidation number of manganese in KMnO4 is +7, and oxidation state of sulfur in H2SO4 is +6. So in this way you can calculate the oxidation state of central atom. In MnO2, manganese Mn has oxidation state +4. In MnO4 -1, Mn has oxidation state +7. After calculation, you come to know this answer. You will come to know this answer. And in H2SO4, sulfur has oxidation state +6. In CrO4 -2, that is chromate ion, the oxidation state of chromium is +6. In dichromate ion, that is Cr2O7 -2, Cr, that is chromium, will have +6 oxidation state. In FeCN6 -3, Fe has oxidation state +3. So by using this formula you can calculate the oxidation state of all the central atoms of any compound. So this is the way or method for calculating the oxidation number of central atom. Now oxidation state of transition elements. See the statement here. Oxidation states of transition element shows large number of oxidation state related to their electronic configuration. So this is the first transition series, and this is the electronic configuration of first transition series, that is 3D series. So scandium has oxidation state +3. So titanium has oxidation state +2 also, +3 also, and +4 also. Vanadium has oxidation state +2, +3, +4, +5. See this electronic configuration. This electronic configuration. See this electronic configuration. Scandium can lose one electron or 2 electron. So scandium can acquire total +3 oxidation. There is total 3 electron in its electronic configuration. That's why scandium can acquire +3 oxidation state. Titanium can lose 1 electron or 2 electron, so it can acquire +2 oxidation state also. If we first consider the electron of 4s orbital. See, when titanium loses 2 electron, it can acquire +2 oxidation state. If one more electron is removed from this shell, titanium will acquire +3 oxidation state. Same way, if one more electron is removed from this orbital of titanium, you will get overall charge +4 on titanium. So titanium can acquire +2, +3 and +4 oxidation state. Same way about vanadium. Vanadium can lose 2 electron, can lose 3 electron, can lose +4 electron and also +5 electron. So vanadium can acquire +2, +3, +4, +5 electron. Okay, so vanadium, titanium shows variable oxidation state. Same way for chromium. See, chromium has +1 oxidation state also, because there is one unpaired electron in its 4s shell. So if chromium can lose 1 electron, so chromium can acquire +1 oxidation state also. But this scandium, titanium, vanadium cannot acquire +1 oxidation state. Why? Because there is no single electron in this shell of scandium, titanium and vanadium. But chromium has one unpaired electron in its 4s shell. That's why chromium can acquire +1 oxidation state also. So chromium can show this much of oxidation state, that is +1 also, +2 also, +3 also, +4 also, +5 also and +6 also. Same way manganese. Manganese can show +2 oxidation state, +3, +4, +5, +6 up to +7. There is total 7 electron in manganese. See, 5 electron in d orbital and 2 electron in s orbital. So there is total 7 electron. So manganese, if remove all the 7 electron, so manganese can show +7 oxidation state. Manganese can show up to +7 oxidation state. Okay. Now iron. See, iron has one paired electron in its one d orbital and all the 4 electrons are unpaired. So this unpaired electron can easily removed, while this paired electron is difficult to remove. So this paired electron will not lose by Fe. So only this 6 electron can be lose by Fe. That's why maximum oxidation state of Fe will be +6. Okay. So there is total 6 electron in d orbital and 2 electron in s orbital. So there is total 8 electron, and manganese show maximum oxidation state +6 because this pair of electron cannot be loosened by Fe. So that's why Fe can acquire maximum +6 oxidation state along with +2, +3 and +4. Same way, if we see cobalt has these 2 pairs of electron. So these 2 pair will not be loosened by cobalt. Only cobalt can remove these 5 electrons. That is 2 electron from s shell and 3 electron from d shell. So maximum oxidation state can be acquired by cobalt will be +4. Okay. Same way for nickel also. See, +5 oxidation state also acquired by cobalt. So maximum oxidation state of cobalt is +5. So in this way it is said that the transition element shows large number of oxidation state related to their electronic configuration. So this variation of oxidation state is depend on this electronic configuration of 3D series or d block element. Okay. So this oxidation state totally depends on this electronic configuration of d block element. Now next, standard electrode potential. See, standard electrode potential is nothing but it is the potential developed at the single electrode at 298 Kelvin due to half cell reaction when an electrode is dipped in its salt solution having unit activity. See, when consider this electrode zinc and this electrode copper. Electrode is nothing but it is a metal rods. So when zinc is connected with copper, zinc will lose one electron, and this electron is transferred through this circuit and accepted by this copper. So here copper are accepting this electron. Copper is accepting this electron and zinc is donating this electron. Okay. So zinc is showing here oxidation and copper is showing here reduction. So during the oxidation of zinc, whatever the potential is developed here, which is recorded in voltmeter. Some voltmeter is also connected here. So this is a voltmeter. So whatever the oxidation potential is measured by this voltmeter of zinc electrode, that is called as a electrode potential of zinc. And whatever the electrode potential is measured by this voltmeter of copper electrode, that is called as electrode potential of copper. So this is the standard electrode potential. So the potential see the potential developed at the single electrode. This is a single electrode. We have learnt two electrodes, zinc and copper. So here zinc is a single electrode or copper is another single electrode. So when this single electrode at temperature that is 298 Kelvin. 298 Kelvin means 25 degrees Celsius. 298 Kelvin means 25 degree Celsius. So at this temperature the single electrode potential is developed here, means developed on this electrode when this electrode is dipped in its solution. Consider this beaker and it is dipped in its solution, and this solution has 1 molar activity, that is 1 molar concentration. Then whatever the potential is developed on this electrode, that is called as a standard electrode potential. At which condition? That is at 25 degrees Celsius and 1 molar activity solution. So this is standard electrode potential. So there is some animation on single electrode potential measurement. You can see on this YouTube.
The potential of the single electrode in the half cell is called single electrode potential. To measure the single electrode potential in copper half cell, we have to connect it to a standard hydrogen electrode and voltmeter. In this case, oxidation takes place in the hydrogen half cell and hence it acts as anode. The reduction takes place in the copper half cell and hence it acts as cathode. Thus, the EMF of the copper half cell is equal to plus 0.34 volt. Similarly, we can calculate the single electrode potential of zinc half cell. In this case, the zinc half cell acts as anode and hydrogen half cell acts as cathode. The EMF of the zinc half cell is found to be minus 0.76 volt.
So here we have seen animation of single electrode potential. So here now see what is the single electrode potential of hydrogen. The single electrode potential of hydrogen is always considered as 0. So this is a standard hydrogen electrode. In short, it is called as SHE, standard hydrogen electrode. So when this standard hydrogen electrode constructed and its electrode potential is measured in voltmeter, we found its electrode potential is 0. So the half reaction, the reaction taken place on this hydrogen electrode is written as like this. In these two hydrogen ion are accepting these two electrons. So acceptance of electron is called as reduction. So here reduction reaction is taking place in hydrogen electrode. So due to this reaction, whatever the potential is developed on this cell, that potential is measured by voltmeter. So the voltmeter showing whatever reading, that reading is called as its standard electrode potential. So whatever the potential is developed due to this reaction, that is reduction reaction, that potential of this hydrogen electrode at 25 degrees Celsius and 1 molar concentrated solution, so that potential we found it is 0, and 0 is a standard electrode potential of hydrogen cell. Okay, so remember the standard hydrogen electrode potential is 0. Now the standard electrode potential of d block element is higher than hydrogen. See, the standard electrode potential of d block is higher than hydrogen. Hydrogen has the standard electrode potential what? 0. So see, this all the d block element, that is first transition series, has electrode potential minus 2.0, 1.60, 1.20, all are in minus sign. So consider these in plus sign. Okay, here it is shown reduction potential, all these are reduction potential, and we have stated this statement by considering its oxidation potential. Okay, in peak, the peak are showing reduction potential, these peak are showing reduction potential, but we are studying according to our syllabus about oxidation potential. So all these terms are in positive sign, all these terms are in positive sign, consider all these terms in positive sign. So all the standard electrode potential of d block element is higher than hydrogen, so all these values are in positive sign, so we have to consider this statement, standard electrode potential of d block element is higher than hydrogen. Hydrogen has 0 value and all the positive values are higher than 0. That's why we have right here that standard electrode potential of d block element is higher than hydrogen. So the standard oxidation potential of first transition series is much higher than SHE except copper. See, here copper value is in negative, don't look about plus 0.34, it is minus 0.34, it is minus 0.34, and all these value are in positive sign. In peak it is a reduction potential is given, and we have to learn by considering its oxidation potential. So standard oxidation potential of first transition series is much higher than SHE except copper. Copper has minus sign while all these terms has positive sign. All the oxidation potential are in positive sign, but copper has oxidation potential in negative sign. Okay, so here copper can lose electron easily. Okay, that's why its value is opposite to all the other element. Now next, reducing properties. See, reducing property means when any substance loses its electron, that is called as reducing property. So losing electron is called as oxidation, but reducing means loses electron. Any substance when loses its electron, it is called as reducing property. See here, when this element lose one electron, it means it is giving electron to this element. Okay, so these X is losing electron while Y is gaining electron. So losing of electron is called as oxidation, and gaining of electron is called as reduction. Okay, gaining of electron is called as reduction, losing of electron is oxidation. So here X is getting oxidized and Y is getting reduced because it is accepting the electron. So this X is losing its electron, means it is reducing Y. X is oxidized itself and reducing Y. So X is nothing but it is a reducing agent. X is a reducing agent. Okay. And Y is a oxidizing agent. Okay. So the substance which oxidize itself and reducing other, that is called as reducing agent, and the substance which reduce itself and oxidize other, that is called as oxidizing agent. So here X is a reducing agent, X is a reducing agent, and Y is a oxidizing agent. See, X is losing electron and Y is gaining electron. X is getting oxidized and Y is getting reduced. So that's why X is a reducing agent and Y is a oxidizing agent. So after oxidizing, X shows increase in oxidation number. That is, X is losing electron. If it lose one electron, it will get plus one charge. And Y is decreasing oxidation. Y is accepting the electron. So that's why Y will acquire minus one charge. If it accept one electron, so it will acquire minus one charge. Minus one charge means decrease in oxidation number, plus one charge means increase in oxidation number. Plus means increase, minus means decrease. So due to acceptance there is a acquire of negative charge, and due to loss there is a acquire of positive charge. Okay, so this is a relation in between oxidation and reduction, and I hope you have cleared what is oxidizing agent and what is reducing agent. See, except copper, all the transition element have higher value of standard oxidation potential. We have discussed this already, that except copper, all the transition element have higher value of standard oxidation potential than standard hydrogen electrode, which has oxidation potential of 0. So hence this element lose electron easily and can reduce other ion. See, all the transition element has standard oxidation potential, means standard oxidation potential are all in positive sign. So all these element can lose electron very easily, except which element? Except copper. Except copper, all the D block element has standard oxidation, positive standard oxidation potential, so they can lose electron easily. This is the reaction of losing electron. When this metal M lose 2 electron, so this M will acquire plus 2 charge. Okay, so this is the oxidation reaction. So except copper, all the element can lose electron easily, and that's why they show positive oxidation potential, while copper shows negative oxidation potential. So negative oxidation potential means it has less power of oxidation and a high power of reduction. So copper can reduce other element very easily. That's why copper is a good oxidizing agent, while other element are good reducing agent. They show oxidation potential high, that's why they are good reducing agent, and copper is a good oxidizing agent. So this is the relation in between oxidation potential, reducing agent, oxidizing agent of D block element. See here, consider this is zinc, that is other metal except copper, and this one is copper. So copper shows reduction reaction and zinc show oxidation reaction. Oxidation means it can give electron, lose electron, and copper is accepting this electron. So copper is showing reduction and zinc is showing oxidation because it is losing electron. So copper shows a reduction potential. copper has reduction potential, and zinc has oxidation potential. Okay, so zinc is a good reducing agent. Zinc is itself oxidizing, so zinc is a good reducing agent, and copper is a good oxidizing agent because it is reducing itself but oxidizing other one. That's why copper is a good oxidizing agent. So all this is about the oxidation reduction reaction, and which element are good reducing agent and which one are good oxidizing agent. See here, if we see this statement, they are less powerful reducing agent than S block element. See, we have seen here that all the D block element are a good reducing agent except copper. Copper is a good oxidizing agent. See, why the D block element are less powerful reducing agent than S block element. See here, if we have already discussed that S element has larger size than D element. We have discussed that the size of D block element are decreasing from left to right. They are decreasing from left to right. So in left there is a S block, and in right there is P block, and in middle there is D block. So S has larger atomic size than D block element. Okay, in this way size are decreasing from left to right. See, if S has larger atomic size and D has a smaller atomic size, so in center there is a nuclear. See, so S can lose its electron easily. Why? Because there is a large distance in between electron and nucleus. So there is no strong electrostatic attraction in between this nucleus and electron. So that's why the electron of S shell can be easily removed. So that's why S is a more powerful reducing agent. They are good reducing agent. See, while D block has a small atomic size, so the outer electrons which we have to remove, they can remove quite hardly as compared to this S, because there is a small distance in between electron and nucleus. So there is a strong electrostatic attraction in between this nucleus and electron. So to lose this electron will acquire a high amount of energy. So that's why D block element can lose not so readily the electron as compared to this S electrons. S electron can remove easily, while D electron cannot lose electron so easily as compared to S. So that's why S are a good reducing agent as compared to D. This is all due to the difference in the size of D block element and S block element. Okay. So this is overall about the reducing agent and oxidizing agent properties of D block element. So we have discussed about oxidation state. What is oxidation state? Oxidation state, it is a charge which is acquired by any central atom after loss of any electron. So that is called as oxidation states. And D block element shows variable oxidation state. Variable oxidation state means they shows more than one oxidation state, that is sometimes +2, +3, +4, +5, +6. So these oxidation states are variable. So all the D block elements shows variable oxidation states. Then D block elements are good reducing agent because they lose electron because they show oxidation reaction easily, and its oxidation potential is higher than SHE. It means higher oxidation potential means all the oxidation potential are in positive sign, so they have high oxidation potential. That's why all the d block element can show oxidation reaction, can show oxidation reaction, except which element? Copper show reduction reaction. Okay, so reduction reaction means copper can gain electron, copper can gain electron easily. So this is all about oxidizing agents or reducing properties of d block element. I hope you have cleared these reducing properties and oxidation states of all the d block element. So for patience hearing, I express my sincere gratitude to all of you. Thank you so much. Take care, stay safe, stay healthy, stay at home. Thank you so much.